It's fantastic to see such a great crowd for the inaugural S3 Solar Software Summit. Before I get started, can we just throw the slides on screen, please? So we're gonna welcome you with some context why we've put on the show today. Again, we are very excited about this topic. We think it's a very important and growing segment within even the more broadly exciting solar market in general. So we look forward to a lot of great discussions. Before we get into that, though, just a few housekeeping notes. For those of you looking for the Wi-Fi password, it is SiteIn. Thank you to SiteIn for sponsoring that. So now you'll be able to tweet or Slack all these conversations that we're having, or share them on Snapchat, or check us out on our Tinder profiles, or whatever you plan to do with your Wi-Fi. Those of you that are signed up for Folsom Labs' Genius Bar and also the demo sessions, they will be out the door and around the corner in the Sevilla and Cordoba rooms. So be sure to check your schedule for that and make sure you get to those places on time. Also, for those of you that are interested in NABCET continuing education credits, if you can't, this will qualify for that. So if you want to get your credits applied, do stop by that Folsom Labs Genius Bar to claim those credits. It's 9 o'clock in the morning, but I'm sure some of you are already thinking about your drinking plans for tonight. So I do welcome you to join us from 5:45 to 7 for our networking reception. And finally, if you're going to be staying with us for the Solar Summit tomorrow and Thursday, do note that you will have to register again tomorrow. But as you've noticed today, hopefully it's a pretty seamless and painless process for you. I mentioned that the software demonstrations, and this is something that we're hosting that's very exciting. Now you get beyond just the conversations that we have on stage, you'll be able to go much more deeper and see how the software is actually working and what it's actually doing. So here's the schedule. Make sure that you do attend those. We'll try to keep a really tight time frame along those and a tight schedule, so make sure you're there on time. Finally, for those of you that are interested and enjoy your experience here, please note that there are additional GTM conferences coming up. Of note is our Grid Edge World Forum that's going to be happening in mid-June in San Jose, California. And also our next solar conference will be in late October in San Diego. Also note that for many of you that are fans of the Green Tech Media site, you might have noticed that we've launched a premium service, GTM Squared. For those of you that need more Eric Westhoff snark in your life, or long musings by Jeff St. John and Julia Piper, or just want another podcast where you can listen to Shiao Khan, opine about the market, please join Square. You get all of that fantastic content, and with the code that you have on screen, you'll actually get more than half off of that service. And I would totally use it if I weren't already stealing Stephen Lacey's access. Finally, thank you to all our partners, especially to Folsom Labs, who came to us with the idea to put on a conference about solar software to begin with. Also, thank you to our other sponsors, SiteIn, EagleView, Nurio, Locus, etc. Without you, this discussion, these insights that we'll be gaining over the course of today wouldn't be possible. So with that, I wanted to take a little bit of time to present why GTM Research is interested in the solar software business, or what we see. And in particular, we see this as an opportunity to really help the industry scale and tackle this big soft cost challenge that we've been talking about for the past, it seems like, half decade, but sometimes frustratingly slow to actually see real results. So why are we here? Well, first of all, in terms of why I'm here, I'm able to be here because even though my wife is 38 weeks pregnant right now, our first baby boy has decided to hopefully hang out for another couple of weeks. But more so for the industry, we know that the industry is nascent. We've seen fantastic growth over the past decade, even the past couple of years. But there's still a very long runway. Solar is still around 1% of the US electricity generation, and we know that it can take on a lot more. So we know that it has tons of potential to grow. And beyond that, one of the things we want to see, especially with the solar software segment and the solar industry as a whole, is that as it grows, we want to make sure we're growing it right. We don't want things to get too messy. We want things to be sustainable. We want it to be profitable. We want everyone to have a growing piece of this growing market. So alternatively, we also want to make sure that we pay attention to competing industries that may not look as fondly on solar as well. But in general, as I mentioned, a big thing that we think about is the soft cost issue, especially within the US space. We've seen that system costs have fallen dramatically in just the past 4 years. And a lot of that's been driven by reductions in hardware costs. Even with module prices stabilizing in the past few years, we still see a 40% reduction in PV hardware. Soft costs, of course, have fallen as well, but not quite as much. And they still account for over 50%, and in fact, almost 2/3 of residential installation costs. Now, one thing to note before I go too far is that soft costs are not just a residential issue. And when we talk about software today, it's not just for residential systems as well. It's a big issue in non-residential systems, as well as even, surprisingly, utility systems as well. So we'll get some of that conversation out today as well. But looking, again, at the soft cost issue, one of the challenges of it is it's not just a PV module, right? You can't just look at it as a manufacturing process. The soft cost issue is one that is incredibly complex because there are just so many processes, so many items that are embedded in that soft cost, right? And so in order to tackle it, we have to look at solutions that are going to not just solve one piece of the puzzle, but solve the entire puzzle together. And so when we talk about software and tools that can improve it, we need to think about things that can help us automate what we're doing, the tasks that we're doing. And we have to do it with intelligence so that it's not just an open platform. We are actually guiding towards right solutions. We're learning from the iterations that we're doing. And finally, again, it has to be integrated within a broader ecosystem so that we're solving this challenge together. And so what are the real opportunities here, of course? Well, one is to help drive the industry to scale. We see a fantastic market in the US for solar. Over 16 gigawatts of solar will be installed this year. That's primarily driven by the utility sector, but still a very strong DG sector as well. And by 2020, we'll see the market near 20 gigawatts. And not only is the annual market growing fantastically, well, this year, I'm sure a lot of you have seen, we eclipsed the 1 million installation mark. And by this time next year, we'll be well on our way to 2 million installations. And by 2021, we'll see almost 1 million installations per year. So think about all the installations that we have currently installed today, and we're going to do that every single year in 2021 and beyond. That's incredible scale that we need to look towards, and how do we solve that, right? And that scale also isn't just the number of installations. It means this growing geographic diversity as well. By 2020, again, this is under business as usual conditions, so what we can see on the table right now, we'll see over 40 states that are in some form of grid parity. And those 40 states, they encompass hundreds of utilities and thousands of municipalities, all with their own local rules, their own local regulations, and their own processes. Again, this is a lot for the industry to tackle. And again, when we think about the growing scale, both in terms of numbers as well as geographic diversity, we have to make sure that when we double installations, we're not doubling effort and as a result, doubling costs as well. Second opportunity we see is this growing ecosystem of long-tailed installers. If you look at the market right now, approximately 46% of the installed capacity last year was installed by residential companies outside of the top 5. And in fact, once you go to the top, even the top 50, only account for around just a little bit under 2/3 of the market. And then the rest of that is literally hundreds, if not thousands, of different installers. And one thing to think about that is that market is scaling tremendously, such that if market shares remain constant, and this is a big if, right? We're not saying that it will, and honestly, this is one of the most heavily debated topics within the GTM research team as well, is how will the long tail versus the large players evolve. But if we kept 2015 market shares constant, you'd see that the addressable market for installers outside of the top 50 in just 2 years from now is the same as selling into SolarCity, Vivint, NRG, Sungevity, and Sunrun. That's amazing, right? We have this a market that's not only growing, but also this group of local and regional installers that are also growing and keeping fairly well in pace with the top installers as well. And so part of the challenge today, and I'm sure something that we'll talk about a lot, is how do we support these installers as well? How do we provide them with the tools and resources similar to what the bigger companies are able to develop on their own? And another thing as we think about how we're supporting these companies is the installation process itself. Sometimes we look at the residential installations, we think, they're fairly simple. They're repeatable, you do them a lot. But it's actually a process that still needs further refinement. If we just walk through a basic process where you have customer acquisition, you get to the contract, you got to wait a few weeks because you're applying for the permits and scheduling, and you finally get to the installation, and then you wait for the utility to drag their feet a little bit and finally give you that interconnection permission to operate, and then you have those long-term operations, right? Well, this process for a lot of installers can take 50 days is like a really best case scenario, right? And a lot of times we're seeing more closer to like 100 to 120 days. It's longer sometimes if there are incentives involved as well. And that's a real problem in the industry because, of course, in the customer acquisition process, you could see some fall off. You're educating this customer, and then they go to your competitor, or they decide not to go to solar. That's a lot of wasted resources, right? That's a big customer acquisition issue. But even beyond that, a lot of times these customers can cancel before you get boots on the roof. And so again, you've spent even more resources, and you don't end up with that customer. And even beyond that too is after the installation is in place, a lot of companies unfortunately don't continue to engage with that customer. And that's a real problem because it can hurt your customer acquisition. It can hurt your ability to get referrals or just simply leave a bad taste in that homeowner's mouth, right? And so all of these things, again, we need better processes. And I'm not saying that software can necessarily drive interconnection timelines down, but we can think about things like engaging the customer throughout this time so that they know what's going on, and you have a process in which you can continue to make sure that all the things that are necessary to get done are done when you're working on thousands of systems rather than 10 or a couple dozen systems. Finally, that long-term operations part is a piece that I think sometimes the industry, we tend to forget about a little bit. We obsess over new installations. We obsess over upfront costs. We at GTM Research sometimes fall into the same trap. But the long-term operations asset management is a big piece of it. We've installed this, and now we think it's going to operate for 20 to 30 years. And there's definitely going to be asset management O&M involved in that, and people budget that in. But for example, if you look at the cost of a truck roll, which can be anywhere between $150 to $400, depending where you are. If you have a couple of truck rolls early on in that system's life, you've basically blown through your asset management and O&M budget. And that can be a big problem if this is a systemic issue, whether it's an installation practice, it can be or even just with the hardware that you're choosing. And so knowing and learning from what you've installed, making sure that that there is this feedback loop from long-term operations to the upfront installations. Again, something that software, something that tracking can better help us tackle. And the thing with that is that, a lot of times this O&M asset management budget is coming out of that overhead and margins piece of it. So again, the better we can take care of that asset management and O&M, the more profitable our companies can be. Finally, all of this, before I close out, is to say that there is a big, it's not like we think soft costs are static, right? We think there's a huge opportunity to continue lowering soft costs, almost 40% in just the next few years. And that's going to help drive over 160% of installation, growth in just the residential sector, and potentially more within the other sectors of the market as well. And software, as we'll discuss today, plays a key role in that. It's not just the solution, but it's a solution that helps us do things more intelligently and helps us plan these systems better. With that, I'm going to, first of all, just close my part of this welcome in saying that we have a really exciting schedule and agenda for today. A lot of great fireside chats and roundtable discussions with some people that have been thinking a lot about the solar software space and what it could do for solar itself. And finally, walking through the value chain pieces so we get actionable intel on what we can do to actually lower these costs or just be more efficient in our processes. And so with that, I do want to turn it over to Paul Grana, who's a co-founder at Folsom Labs, who will talk a little bit more about how solar and solar software can co-evolve the space.
Thanks very much, MJ. Pleasure working with the GTM team on this. It's fun to have everyone here for the first year. So as we at Folsom Labs thought about software and how software and solar sort of intermingle through the last few years, we started to think about two concepts, really, technology versus innovation, and how they're similar and how they're different. And one of the important ways that we think that we can learn about how software can play with the solar industry actually goes all the way back over 100 years to the Industrial Revolution. And specifically the way the Industrial Revolution actually electrified, the way they adopted electricity. So around the end of the 1800s, the factories began to adopt electricity. It was actually, by the way, pushed hard by Edison Electric, the utility, because most of their load was lighting at night. And they saw the C&I segment as a great way to sort of load balance their actual electricity demand, which would really help their economics. So utilities playing a key role there too. So as the electricity was pushed into the factories, over a period of 20 years, we actually saw electricity penetration go from 20% to 80% of the C&I segment, going from steam to electricity. However, over that same 20-year period, the productivity actually fell of the plants, actually by 20% over that 20-year period. So, of course, that seems like it makes absolutely no sense. You've got this great new technology. It's got lower cost. It's a higher efficiency product. But it does nothing for the factories that it was actually trying to help. So the question, of course, is why? Why didn't that work out? And to understand that, we have to look at the way the factories are actually designed. So here's an example of a sort of pre-electrification factory. Along the top, you see those pulleys and beams. That's actually the way they power the factory, was a central source of power, typically the steam boiler, and then a line drive that runs through the factory. That then powers countershafts. So as that crank turns all day, these countershafts are turning, and then they power the actual tools throughout the factory. So when these plant managers adopted electricity, what did they do? They shifted the source of power, and then basically ran their plant on electricity. Now, this had a couple of benefits. The cost savings were 20 to 50% on their power basis, but the cost of energy was typically around 5% of the total production cost. So we're talking on the order of 2% benefit in cost structure. Sure, there's a benefit, but pretty small. And they were cleaner, and they were sort of like easier to use, but that was about it. So again, did nothing for the productivity. And for 20 years, this was the state of the art. This was how the factories were run. And there was very little impact on the way the factories actually were able to output products. Now, part of that is because, again, people were basically replacing the technology, not redesigning the actual process around the technology. And it wasn't until GE started to commercialize a whole new way to think about the electric motor. Because they were more versatile, they were able to redesign the lines and have multiple lines running at the same time, batching up their work processes. In fact, they then took that even further and started to pair the electric motors with the tools themselves, which gave a ton of benefits. You could now start to batch up the actual machines. You could start to shift the work around based on demand. They were specializing the motors based on where you needed power versus torque. And they were, when there's maintenance, again, in the old world, when there was a problem somewhere on that line shaft, the entire factory was down. In this new world, if there's a problem with a machine, you lose a machine. So over the next 20 years, this is really the new plant of the future. You notice there's no overhead lines and cranks. And from 1920 to 1940, productivity then increases by 80%. There are tons of examples of a specific factory with no change to the size of the factory, to the actual labor and capital plant, increasing by 30 to 50% of the output, just because they can redesign the way the actual factory is actually laid out. So basically, again, the lesson here is there's a big difference between technology and innovation. Just because you sprinkle technology doesn't actually get you benefits automatically. Really, you have to understand how that technology can fit into the process, to the context, and to the objective of what you're doing. So hopefully everyone can see the example, or where this maps to software today. So we have software tools that are wonderful tools. But if all we do is adopt the software tools and change nothing about how we work, then we've only scratched the surface of what the opportunity is. So really, most of the trouble, most of the challenge, most of the opportunity is actually rethinking how solar developers work today, big and small, to fundamentally improve how they're able to actually increase their productivity. The way we're going to reduce soft costs is not by looking at a line item and making that line item smaller. It's going to be to say, how can I make my team 50% more productive? Software can help, but software by itself will not get you that. So luckily, fast forwarding to today, we are seeing examples of this. And we call this theme the coevolution theme. In the sense of coevolution in biology, you typically have two biological systems working together. And as they evolve, as there are changes in one, it leads to changes in the other. And it often sort of cycles back and forth. So we see this with software tools. So starting at the beginning of the customer process, we're seeing lots of examples where customers are becoming more educated before they even call up the installer, getting multiple quotes, comparing things before they go in, and really sort of entering the process in a more educated fashion. Then once they start to talk to that salesperson, by the way, thanks for Sunrun for the picture here, we're seeing this process change a lot too. So we're seeing salespeople way more empowered. So instead of having a sales engineering team or an engineering team, often that salesperson is able to triage whether this customer makes sense, put together the proposal on their own without bugging engineering or finance. And then, as you see point 3 here, when that customer has questions or requests on how they want to see that system changed, now the sales team is empowered to actually make that change with the customer on the fly. Now, again, because there are good software tools that do it, but the key value isn't just the good software tool, it's getting that customer engaged when they want to be engaged in how their system looks, in what technology you're using, in what a different technology will mean for perhaps the yield versus the cost of that system. So that's, we're fundamentally seeing that sales process change. Putting that in context of the organization, this is sort of illustrative, but it's a lot of the things that we hear from actual users, is that a lot of the value is actually in front loading as much as possible. So basically, in the traditional world, if I can go back, you often have to bounce between sales and engineering, sales and finance to be able to put together the actual contract. But with software tools and with good training, you can start to have that front-end team, whether it's the sales team or the business development team, really empowered to do as much as possible. And again, if you think about what this means, and again, all these bands here are shown as equal, but the engineering team, the finance team is more expensive. They tend to be more bottlenecked. It's hard to scale up an engineering team quickly. It's not as hard to scale up a sales team quickly. So again, mapping enabled by software tools, but the key thing is how can you map your process? How can you shift tasks from one part of the organization to another so that you can scale them up faster, perhaps reduce the cost basis, but more importantly, meet customer demand faster and get more out of that same team. Have more out of the engineering team because now they're leveraged across a much bigger sales team, for example. Mapping that forward, we also see changes in how systems are designed, again, enabled by software. In the traditional world, you see the examples on the left. This rooftop might be a 70 kilowatt array, but now with a lot of new technology, some software, some not, we're seeing lots of changes. Lower tilt, tighter spacing, usually is better in the era of low hardware cost. Larger DC to AC ratio. And you see the greater shade tolerance as a really important one as well. Again, in a world where there's no way to properly understand the losses from shade, you have to be conservative, right? That's the responsible thing to do. But when you have tools that can actually tell you that if you get this close to an obstruction, yes, you will have losses. But again, in an era of low hardware costs, that's usually the right thing to do. So what we're seeing consistently is customers that are doing their homework are finding that it's optimal to get closer to the obstruction, to have more shade by design, on purpose, because it's better for the overall system economics. So again, the system designs are now sort of co-evolving because the software tools allow the responsible engineers to sort of do their work better and figure out what makes economic sense. Another example of how software changes an ecosystem, now on the AHJ side, there are a number of companies developing automated permit documents. And it's not just us. You see examples here from Solar Design Tool and Solar Nexus. Or I should say the screenshot is Helioscope, but there are other companies working on this as well. The interesting thing here as well isn't just that there are these new products on the market, but as these products come to market, we're starting to see inspectors say, as these come to market, I can evaluate the tool, and I can actually just green light anything that comes out of that tool. And to be honest, we hear so much about how adversarial relationships get with AHJs. But when we actually talk to them, what they actually said is, look, I don't have enough time anyway. And so if I can take all the calculations that are done by hand, and I can say, OK, 2/3 of those are done by software, so I just don't have to check them as long as the output is within what I need, I can then narrow the band of what I need to do to stamp a permit application. So it's actually in their best interest. But what ends up happening is you start to have a slightly better workflow through the AHJs. I'm not promising the world. As we all know, those guys can still do whatever the heck they want. But we're seeing at least some slight changes towards a happy relationship there. Again, enabled by software tools, but the important thing is what it does to the human interaction, to the way the documentation works, and to the way that workflow works. Similarly, on the finance side, here there's a very dynamic market that we're going to hear about this afternoon. But consistently, the trend is towards standardization as much as possible, which benefits the financiers, benefits the originators, and it's driven often by the software tools who can start to implement consistent structures for financial terms, for legal terms. And then as people get sort of normalized around that, again, it's great for speeding things up, for reducing those costs, and overall sort of helping us deploy solar and deploy capital more efficiently and more quickly. And then finally, just to talk a bit about APIs, because I'm sure we're going to hear about APIs through some of the panels today. What you see on screen is one of the examples of something that's commercially available now, but it's the first of many. So this is a case where any user can start from a design they've done in Helioscope, then send the entire design over to Unirac's UBuilder, and automatically have the entire set of engineering calculations done by Unirac. So essentially, you can have the system design and layout done based on shade analysis and spatial layouts and code requirements, and then have all the detailed ballasting calculations, wind load calculations, even a stamped engineering letter right from Unirac's tool. So that API, and by the way, for those that don't know APIs, I'll just quickly mention it. It's basically a way to automate two systems so they can talk together automatically. Again, we'll probably hear from the folks at Ecotisa because they've got that as well. But basically, it really helps you tie together different tools when they're both good at different things. And when the user wants to be able to have that flow go, not have human error in between, not have man hours as a cost in between. So, but that API generally doesn't just, again, it's not just a way to reduce cost between 2 points. It actually can change the way the software ecosystem actually works. So as we're seeing a number of API relationships that, first of all, that can just streamline the workflow based on the standard workflow, taking in a lead from a source of that lead, running through the CRM, running through the design, running through the finance, running through, finally through to price it out from a distributor and monitor it with a monitoring product. But then also, in between there are tons of opportunities to fundamentally change what software means, fundamentally change what products are available. So one of the things that we're actually starting to see is a whole other ecosystem of emerging software applications. So what a lot of people talk about, and what I'm sure we're going to hear today is, is this build versus buy, Sunrun versus these software products. But the future isn't necessarily all solar cities, and it's not necessarily all monolithic software applications. We actually are starting to see, and we strongly believe, that the future is going to be even more software products that are smaller and more specialized. So we consistently hear from iPhone app developers, or smartphone, I should say, app developers, who are working on a very specific problem. Maybe they're working on how to automatically tell a 3D layout based on a smartphone from someone standing on the ground, kind of attacking the post-Sun Eye world. We hear from people working on AHJ problems. How can they develop an AHJ database? How can they develop tools to engage AHJs? Very specific problems, very technical problems that, to be honest, I don't think anyone's really working on, or I'm sure they're working on, but no one's solved yet. And those companies can via APIs can basically tie in and have a product that's a profitable product, a product that makes sense for them to do. They don't have to build a business. They might not have an accounting team, a sales team, a support team, a finance team. They can have a product that they can sell and have a very happy business. It might be a 1 or 2 person company. And so again, that API ecosystem actually reduces the sort of minimum efficient scale for a software company. So again, as we think about this software conference as the first of a 5 or a 10-year plan, I think an important thing to think about, and my strong hunch is 5 years from now, there are going to be more software products than fewer. Because the trend is not going to be towards consolidation. It's going to be towards the big companies getting bigger, but a lot more flourishing of other companies that can work with those big companies to have very profitable, very specific solutions that don't require the full infrastructure, the full investment of a true software company. So finally, tying it together again, these 2 guys on the left side of the page took 20 years to figure out how to get the benefit of electrification of their factory. We do not have 20 years to figure out how to get the benefit of software tools. And that's why we're all here today, to basically not just understand what's on the market, but understand what those products can do for our businesses, for our workflow, and for our processes. So with that, I will hand it over to MJ.